In this video, we are going to look at why is it essentially for having a conditional mean. It's a condition for stationarity for our means in terms of different variables. And today's points we'll be looking at how different variables can be stationary, maybe my x or my y, or to not be stationary graphically in terms of looking at the how the means are changing alongside the time. Uh, to to make it clear, so we start with what we call the expectation. The expectation of my xt is always equal to parameter u. It's a first principle for the mean. That's what I am expecting. Xt should be equal to my mean, which means the sample size is closer to the population mean. And when we plot with our Cartesian plan, we will have our xt and for the y, and then for the t, for the x to have t. And when we are drawing the line, it is showing that it can move ups and down, but with an upward trend. So this is my x, the evolution of my x. Let us also draw another one. This is an indicator of evolution of 1x. Let's assume maybe we have we are looking at something that is moving. As you can see, the mean, for example, let me just highlight the mean of here and the mean of here is different. So I can have an x bar. I can have an x bar. I can have an x bar 1, x bar 2, x bar 2, 3. So the mean is keeping changing alongside the time. And let us put another Cartesian plan for you to understand as quick as possible. Let us still have my xt alongside with t, and I'm still having what we can call like the evolution of my information is keeping go back and forth. So but when I bypass when I bypass a line, the line is bypassing through all the points with one mean. So there is nothing changing in terms of the mean, even though it is going back and forth. But the mean is a bit similar for each and every point for the second scenario. And conversely, let us look at for two variable that is going in different direction or in the same direction, but one is affecting another. Let me assume I have yt equal to alpha naught beta 1xt plus the error term. And I want to look at the evolution, how alongside the time my xt and yt is moving. I can just plot my x. So my x, let me just start with my y. It's going to be moving like this one constantly. But on the other side, when we look at the xt is a bit going down for the first stage, and then for the second scenario is going up. This is my xt, and this is my yt. When you look at this first scenario, For the first case, you realize that my yt here is greater than the xt. But on the other side, it's another scenario. It's that my xt is greater than my yt. So if I'm going to, if I'm the one supposed to, if I'm supposed to write an equation, I'll be writing that for the first session, my yt was almost double of my x2 xt, and for the second session or part, my yt was a half, 0.5. So you can see that the meaning is changing. This is one case, but we also still have another Cartesian plan. Keep changing. We are looking at maybe this is my consumption xt. Let us call it a x to be a consumption. Oh no, it's an income, and then yt to be a consumption, because the more income, the more consumption too. Alongside the time, it's possible that my yt, or the consumption that I'm holding, to be evolved from these points and then up, and then my income also to be starting on above, and then at this stage it is going down because I'm just consuming a lot, or I'm just losing the job. So the gap between here is a bit the same, but when you see here, there's a difference. The fact that there is a crossing each other, you can't say that all the two variables are stationary. When you're supposed to write your equation, it will now be your x, your y, and even also your x is not stationary. One is an upward trend, the other one is a downward trend. The one is having a big slope, and the other one is not having a big slope. Xt plus the epsilon. So what do I mean? What do we say the conditional for stationarity means? So the purpose of this session was to look at, is it possible that I can have my xt, but also on the other side having my yt, which is also stationary, so that we can just confirm the assumption, the OLS assumption, classical linear regression assumption. And it's possible. So how, in which case it's possible? I should have, for example, if I should have maybe my yt here, which is also moving like the way it is moving, as long as we are looking at the gap between my yt against my xt is a bit constant, we can say that our equation will be stationary in terms of our mean. So this equation, the last equation, will be acceptable because the way my yt is changing respect to my xt, there is a constant. There is a constant within it. There is no variation of one side to the other side, like the way we used to see in the first scenario of having a scenario 1 and then a scenario 2. But here you can see that all the scenarios are the same. That's why we conclude by saying our variables, though we are dealing with a lot of variables, that one is affecting the other, we should have a constant or a stationarity in terms of the evolution of those variables alongside time. Thank you.